let's see. Just now we have seen the phases of compilation, two phases of compilation. Now these two phases of compilations, it is being designed with a lot of modules. These are all the different modules of a compiler. You can see that first one is lexical analysis, syntax analysis, semantic analysis, intermediate code generation, machine independent code generation, code optimization, and machine dependent code optimization. So here, if you see this portion and this portion, there are some inconsistencies. If you note, here I have written analysis, generation, optimization, but here you can see analyzer, optimizer, and everything. See, both represents the same thing. Here the tool is being analyzed. Lexical analyzer is a tool that does lexical analysis. Syntax analyzer does syntax analysis. So these are all the modules of compiler: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, and code optimization. See, this code optimization module is being split into two portions: machine independent optimization and machine dependent optimization. We will learn all these in 5 modules. This is in module 1, module 2, module 3, module 4, and generation and optimization taken together will be discussed in module 5 in detail. See, earlier we mentioned that a compiler has two portions: analysis and synthesis part. Analysis part comprises of these three phases: lexical analysis, syntax analysis, and semantic analysis. Three analyzers. It comprises of the analysis part. Synthesis part, we have intermediate code generation, and code optimization modules. This is how things go. And this portion is called as the front end of the compiler, and the later parts are called the back end of the compiler. That also we have seen earlier. Now let us see how a quick brisk view of what's happening in lexical analysis. So as you can see here, this is a diagram representing a lexical analyzer. Input is the program as such, that's called as character stream, and output, you can see that it is a set of tokens. Let us see what's happening here. See, the lexical analyzer, it gets the source code as the input. If x greater than 3 minus 1, a portion of an if expression. For us, it's a portion of a statement. But as far as the lexical analyzer is concerned, it is a stream of stream of characters. Now this stream of characters will be read by the lexical analyzer. Now the job of lexical analyzer is to identify which of these are reserved keywords of a language, which of these are variables, which of these are values, which of these are operators. This distinction has to be made by the lexical analyzer, and depending upon the character stream, received, these character streams will have to be split into several portions by the lexical analyzer. And such portions are called as lexemes. Each lexeme is a meaningful portion with some meaning, with some purpose. Let's go back to the earlier slide itself. See here, you can see that if I as taken as such has no meaning as far as a language is concerned. So how the meaning will be assumed? It is not the fancy of the compiler designer. Compiler designer will have to refer to the language manual. Suppose that we are developing a compiler for say C language. The designer of the compiler will have to verify the C language manual how the keywords are being specified. What will happen if an if keyword is specified? What should be followed by if? These things will be clearly mentioned in the language manual. As per that language manual, lexical analyzer will have to group these stream of characters into meaningful sequences called as lexemes. So lexeme, remember lexeme is a meaningful portion of a character stream. Here if is lexeme, this left bracket is a lexeme, x is a lexeme, this operator is a lexeme, 3 is lexeme, all these are lexemes. Now for each lexemes, lexical analyzer, once a lexeme is identified, lexical analyzer will have to decide whether it should be added to the symbol table or not. When a lexeme is added to the symbol table, it will have a tuple like this, a token name and an attribute value. So lexeme, a lexical analyzer will produce a token for each meaningful sequence. Token name is the name given for a token, and attribute values are what is the ID of that value in the symbol table. Let's take one more example here. Position is equal to initial plus rate into 60. This is an expression, say in Pascal language. Here we have 3 operators, assignment operator, and these are obvious for you. Here we have this P and till N. It is one meaningful sequence. It's a lexeme. This lexeme will be identified as an identifier position. It is given a name, token name as ID1, and 1 is the index value of ID1 in the symbol table. Second operator is represented like this, equal to. Third identifier, again it is identifier, so we name it as ID2, second index. This is added. Third symbol is rate. Rate is again an identifier. So hence, once these lexemes are identified and corresponding tokens are defined, the statement that were given in the high level language was reduced to this shape now. ID is equal to ID2 plus ID3 into 60. This is a job of lexical analyzer. See, whatever statements we have made is lost now. All these identifiers are substituted with token values. Now for the further stages of compilation, instead of our higher level statement which is present in higher level language, compiler will be using this statement for further translation. We have taken only one statement. The entire program will have to be scanned, lexemes will have to be produced, and wherever possible, symbols will have to be added like this in a symbol table.